Hey, what's up, YouTube? Let's try to do one in 5 minutes. Let's see how that goes. I wrote down some bullet points. Let's stay on topic. Who are you? That's the number one question I've gotten from a few people in chat and otherwise. My name is John. Hello. Welcome. Welcome to my channel. So I am a software engineer. I've been working in Silicon Valley at some of the biggest companies, Apple, Google, Lyft, and one other. I've been working in iOS development for the last 10 years or so. My team at Google was laid off about 2 years ago, so I've been somewhat on sabbatical. I've been trying to shift from working at a big company to doing my own thing, to doing my own indie projects. I've been dreaming of becoming an indie app developer. And that's been really hard. I'm finding that. And a lot of people have said, oh, what's your social presence? Like, what is your social strategy? Are you on TikTok? Are you on YouTube? Etc. I'm like, I don't like social media. I don't like the normal way of doing social media. That brings me to the next point. So what am I doing here? I am practicing. I am trying to explore deliberate practice as one concept. There's this book, I'll grab it real quick. I recommend it to everybody. It is the best book, in my opinion, to study and talk about craftsmanship and deliberate practice. Cal Newport, so good they can't ignore you. I've been ignored a couple of times, especially on entrepreneurship and apps that I'm building, so that's fueling me. So why math? I studied math like 15 years ago. I was a pure mathematician. I was aiming to become a professor in grad school and go to grad school and become a professor and all that good stuff. I decided not to do that because I was like, you know what, this iPhone thing, it's going to change the world. I really think that this iPhone, that there's something to it. And I think that was the right call. I'm just going to say it. I think AI took my job. It took it literally and metaphorically, both of them. I was at Google when ChatGPT was released. I saw the internal reaction to ChatGPT in Google and just like the flurry of docs that people were creating, like testing this thing and seeing how good it was and debating what's the impact of this, like if you have a much better search engine. And I told my coworkers on that day, I was like, I've been paying attention my entire life to AI, and this is the first one that I think actually could take software jobs. And they were like, no way. And I was like, I really think it might. And then 2 months later, Google lays off like 12,000 Googlers, including not just my team, my entire team, the team next to mine, our vice president, like the entire org under our vice president. And so that's like, even in the blog post, they mentioned like we're focusing on AI efforts. I think it just signals kind of like a change from it signals this change from the era of the iPhone and the smartphone and whatnot to AI is like the new hot thing. The same way I was like, this smartphone thing, it's gonna change the world. That's a little passé right now. I'm finding nobody wants to try out new apps and whatnot. So I talked about that a little longer than I wanted to. So I right now am really interested in rebuilding math as a hobby for myself. I don't know if we're going to head into solar punk or cyberpunk, but in either case, I think AI is going to change everything, and we all need to get hobbies. We all need to get deep hobbies. I love the idea of deep hobbies like classical guitar for me, or pure mathematics and just studying math, like things that you can do the rest of your life and just pursue deeply, like a craft. And so those are a few things that are going to just pop up again and again. in all of this in this channel. The last thing I wanted to say is, like, not only did I work at Google, I worked specifically on YouTube, and I was doing so much extra work to try to shift into product design. That's this yellow book right there. And so, I don't know, right now this is also me exploring all the product areas, the little crevices, the little nooks and crannies, like really trying to understand YouTube as a product and its product design. Because if I go back to a tech job, I think I want to become a designer. And so math is my hobby. Math is my love, my passion, especially abstract algebra. I'll just say, like, as a hobby, over a long time horizon, over the rest of my life, I want to work toward understanding Fermat's last theorem. I want to understand every detail behind Fermat's last theorem. I no longer want to be a professional mathematician, but as a hobby, I want to understand that math, skip other math that's not necessary for it, I think, and in the process contribute to the formalization of Fermat's last theorem. It plays really well with my passion about software quality and just getting software to be rock solid. Like the new efforts in Lean and the MathLib formalization efforts, it feels so similar to what I've done in the past in software. So I'm really excited to learn those tools and share my journey learning. So I think we're at like 7 minutes or so, and that's okay, right? Shoot for the moon and whatever. Land in the stars, or shoot for the stars, land on the moon, whatever the heck it is. So thank you for watching that. Bye. And now we are going to study mathematics. We're just going to hang out and study some abstract algebra. I hope you all enjoyed that little short channel intro. I'm going to clip that tomorrow morning and upload it as a little channel intro. How's it going? I see we've got a couple people hanging out, viewing. What's up? What's going on, y'all? What's going on? Yeah, there was like one more topic I wanted to hit, but I think we got the main ones in. No, I forgot to mention remote work and how right now. Nah, that's like kind of secondary. I can skip that. It doesn't matter. What's up? How's it going, y'all? We got to start time boxing time in math, because it doesn't feel like it's really going places. So let's set the hour-long timer. Haven't shown this one as much. Alright, we got an hour that I can budget into math today. As much as I love it, let's budget an hour. Cool. Nope, that's not the one. Why do I have so many? iPad horizontal plus Sony. Why? I am super confused. There we go. There we go. Now I got some math up on the screen. Okay, so I wrote down a ton of exercises. Let's actually solve some exercises, because you can't just copy math and not actually do math. Solving every algebra problem. I wrote down the first problem statement from every group theory section from Dummit and Foote. And so here's my little table of exercises. let's try to get the first one from the first few. So chapter 0 is like preliminary stuff. And we can try to what am I looking for? What's the word that I'm looking for? We can try to solve some of these, at least. There was something else I was going to say, but whatever. All right. Okay. Dummit and Foote exercises. I will record whenever we have some of these that I feel I can actually record and upload as a clip. So let's record this one. Why not? Okay, so if I do iPad vertically like this, and then I switch, does this work? That did not work. Oh, I know, because I renamed my iPad to Dopamine iPad. What a name, right? What a name. And for whatever reason, that needs to get bigger again. Okay. Yeah, let's keep it like that. Okay. So, Dummit and Foote 0.1.1. I think we can solve this one live. I think we can do this. So, 3, 2, 1. All right, so let's solve this problem. 0, 1, 1. A is a set of 2x2 matrices with real entries. M is this specific matrix, and then fancy B is going to be the set of matrices, of 2x2 real matrices, such that the matrix is commutative with M. So mx equals xm. So which of these are commutative with M is essentially what this question is asking. So why don't we figure that out? I want to duplicate this a few times. I don't want to rewrite. Well, whatever. Let's just rewrite things. It's fine. Okay, so in our solution, let's find out if this is A, B, C, D, E, F. When X is 1, 1, 0, 1, the question is mx equal to xm? That's our question right now. So let's find out, what is mx? M is always going to be, this is the only time I'll write this one, 1, 1, 0, 1. And then mx is 1, 1, 0, 1. And then the other matrix is this. And then xm is going to be the matrix in question multiplied by 1, 1, 0, 1. And if these two are equal, then the matrix X is in the set B. So this is going to be the template for every part. So why don't I yoink all this? Oops. Why don't I rearrange those? Grab this, move it over a little bit, give that a letter name, duplicate this all a few times, Oh, I can't. Okay. Duplicate. 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 I don't know if that's the right number. We have something like that. And now, when the matrix in part A is 1, 1, 0, 1, like this, 1, 1, 0, 1. In part B, 1, 1, 1, 1, 1, 1, 1, 1. In part C, 0, 0, 0, 0. I'm confident that that one is going to work. 1, 1, 1, 0. 1, 1, 1, 0. 1, 1, 1, 0. And then 1, 0, 0, 1. 1, 0, 0, 1. 1, 0, 0, 1. And then 0, 1, 1, 0. Hey, I counted, or I just guessed the exact right number of duplications. Okay, so let's do these matrix calculations. So this is going to be 1, 2, 0, and 1, right? And then if we flip the 2, then we get 1, 2, 0, and 1. So that one is in the set Fancy M. Now on this one, we've got 2. Why don't I do each entry one at a time? So, all right, right off the bat, this one is not. Boom, it's not. Because then we can avoid some unnecessary calculations, right? 0, 0, 0, 0, yeah, that one's going to be, this is absolutely going to be zeros. 1, 1, 1, 0. So this is 2. The first entry here is 1, and therefore this one is not. Part E, we've got 1 in the first coordinate, and then on this one we also have a 1 in the first coordinate. We get a 1 in that upper right spot. We also get a 1 in this upper right spot. Bottom left entry is 0, and bottom left entry is 0. So far, so good. 0, 1, 0, 1. All right, so this one does. So this one is. And then F, our final, F for final, right? We've got 1, yeah, so that's a 1, and this one is a 0, so it is not in the set. Okay, thanks for watching that. There is the first exercise from Dummit and Foote, and we're going to solve every exercise. We're going to solve every algebra exercise. Done. There's number 1. All right, thanks for watching. Bye. Cool. So there's our filming of one exercise from Dummit and Foote. Cool. Let's give it a tally or something. I don't know if I'm going to remember that. I don't know, a check mark. Let's give it a check mark. Why not? Let's solve another one. Dummit and Foote exercises. Let's get the first exercise from section 2. This one I'm not ready to record yet, but let's finish it. Because I started this the other day and I wasn't able to finish it. I know how to calculate the GCD using this algorithm, Euclid's division algorithm, Euclid's algorithm to calculate the greatest common denominator, greatest common divisor, I mean. But I don't know how to unroll it correctly yet. So let's figure it out. Let's at least do the first part. Each of them have 3 different parts to it: GCD, LCM, and linear combination, right? So for now, I just want to work on the GCD of each. GCD of 20 and 13. So let's again try to duplicate this template. It takes some space, so let's give ourselves some. Why the heck? What? Again, duplicate. Let's try to do 2 per page. I don't remember exactly how many there are, but we're getting somewhere. There's 6. 1, 2, 3, 4, 5. One more. Okay. I'm going to be okay with the fact that the list, like A1, is incorrect on each A. Each of them say A. Nah, you know what? Let's do it the right way. Whatever, who cares? Let's not waste time on that. 20 and 13. 69 and 372. 792, 275. 792 and 275. 11391 and here, let's copy this over. We're just going to have to rewrite little bits. We've got 11391 and 5673. 1761 and 1567. 507885. It's huge. That's crazy. 507855. And 60808. Cool. Okay. So we've got our nice little template. Let's actually solve these. So the way that the algorithm works is we're going to write the first as we're going to remove as many multiples of the second of the smaller number from the larger number. And so 13 divides into 20 one time with remainder 7. And then we write the prior divisor as a multiplication of the remainder. So 13 is 7 plus 6, and then 7 is 6 plus 1. And then, how do we know that we're done? I guess when there's no remainder left, then 6 is 6 times 1. So I didn't write explicitly like 1 times, but that would probably make things clear. 1 times 1 times 13, 1 times 7, 1 times 6, 6 is 6 times 1. So, therefore, the GCD of those two is 1. Because this was the number that we ended up with. Like when we divide by that number, finally we have remainder 0. And we keep following this algorithm. Each of these kind of move over like this. Okay, so let's write out these. So 372. So I think that 69 will go into 372 5 times. All right, so 5 times 69 is the same as 5 times 70 minus 5. 5 times 70 is 350. And then minus 5 is 345. And 345 is 27. This is a great opportunity to try to practice your mental math. Let me ask ChatGPT. Was that correct? 372 divided by 69. It's going to give me a decimal. But I guess I need to, if I ask ChatGPT, 5 times 69, 5 times 69 plus 27 is 372. What? I'm so good. All right, and then we take the prior divisor, and then we divide it by the remainder. So that's 2 times 27. 54 is 15 away from 69. All right. And then that divisor, 27, is 1 times 15 plus 12. 15 is 1 times 12 plus 3. And then 12 is 4 times 3 plus 0. Therefore, the GCD, the greatest common divisor, is 3. For these two, 792 is 2 times 275. 2 times 275 is the same as 500 plus 50. Yeah, 550. And then 550 is 200 and 42. Did I get that one right? 2 times, I think so, 2 times 275 plus 242 is 792. Look at me. Look at me and my mental math getting better and better. Okay, and then 275 is 1 times 242 plus 33, right? 33. 242 is, it looks like it's going to be 7. 33 is going to divide into it 7 times. 33 times 7 is 210 plus 21 is 231. 231 is 11 away from 242, right? And then finally 33 is 3 times 11. So therefore, 11 is the greatest common divisor of those two. I think that these are just very fun, I think. 11,391 is going to be 2 times 5673. 2 times 5673. I'm not going to do that one in my head, but I'm also not going to cheat. 5673 times 2 is 6, 14, 13, 11. Oh, wait, 11,3. Yeah, no, 11,346. I was right. And then 11,346 minus. Oh, wait, no, 11,391. 11,391 minus 11,346. I could have done that one. Come on. All right, so that's the same as 46 to 91. How far apart are 46 and 91? 55. Yeah. Oh, wait. No, what am I talking about? 45. 45. Yeah, we can do that. Come on. As soon as you start getting lazy, we can do this. All right. Now, 5, 6, 7, 3 is, how many times does 45 divide into that? Well, any tricks here? It's not going to divide evenly because 45 is a multiple of 5 and 5673 is not a multiple of 5. Yeah, let's just do it. I mean, my guess, let's see, 4,500, so we can multiply by 100. It goes in 100 times, and then 1173. 45 goes into 1173. All right, we're just gonna do it the old-fashioned way. 5673 divided by 45 goes in there once. 11, 7 goes into that twice. 90, 27, 273. 45 goes into 273. Well, 90 goes into 270 3 times. So then this is 6. Because 2 times 45 is 90. How's it going? What's up? Come less tricky teacher. What does that mean? How's it going? I see that's your handle. Welcome to my stream. YOLO, how are you? Abhinav, how's it going? All right, so where were we? Yeah, 6 times 45 is 270. I believe. We're doing all this with mental math. We're taking the opportunity to practice some mental math right now. Okay, so then that's 3. So remainder 3. 126, remainder 3. 5673 is 126 times 45 plus remainder 3. And then, well, 45 is definitely 15 times 3, and we are done. So I believe that the GCD of these two is 3. Are using the Euclidean division algorithm? Yes, that's exactly what we're doing. Good catch. Good catch. Did I write these backwards? 1173. Those numbers are much bigger. 11,391, 5673. Here's a problem statement if you want to try them yourself. I don't remember how to get the LCM and the linear combination through an algorithm type of way right now. So I'm going to have to review that. But yeah, I at least wanted to solve the GCD part of each of these. 1761 is 1 times 1567 plus, how far apart are those two? It looks like 200 minus 6, right? 194. Did I get that right? I think so. 1761 minus 1567. Yeah, 194. Got that. 1567 is, let's see, so 200 would go into 1400 7 times. So I think it's pretty close to that. But let's get it. Let's just write it out and get the remainder as well. 1567 divided by 194. 194, I believe, goes into 1567 7 times. So 7 times 4 is 28. 7 times 9 is 63. So we've got 65. And then 7 plus 2, something went wrong here. I did this wrong. I did this wrong, didn't I? 7 times 24 is 28. 7 times 9 is 63. 63 plus 2 is 65. Yeah, I wrote down the carry wrong or something. 7 plus 6 is 13. Yeah, I don't know what happened there. Let's see. Okay. Yeah, no, it goes into it 8 times, doesn't it? Or not? No, it does, because that's more than 200. Those two are more than 200 apart. Dude, let's try this again. 8 times 4 is 32. 8 times 9 is 72, so we got 75. 8 plus, so 15. 52, so that is 15 difference. So 1567 is 8 times 194 plus 15. 15 does not divide into 194 evenly. 194 divided by 15. Let's be lazy. 15, 44. 15 goes into 44 twice. Remainder 14, right? So 12 times 15 plus 14. Then 15 equals 1 times 14 plus 1, and then therefore 1 is our GCD. And then I am about out of time. We're at an hour. I see my sand timer finished, so we're just going to finish this last part. Whew! 507,885 equals something times something times 60808. Whew! 507,885. I've seen another kind of guess and check way of doing division that this would be quite useful for. So I know 60808. Let's see. You know what? I think Dummit and Foote they are assuming that you can reach for a calculator. 507,885 divided by 60808. There's better things to do with our lives right now. So this is going to be 8 times 60808. And then 21, 421. Then 60808. I think that's going to go into it twice. $60808 minus 2 times 21, 421. Whoops. 21421. 17,966. So we're still working. Everything is still working out. 21421 is 1 times 17,966 plus 4,000. Whatever. Let's do it. 4,000 something. We could do it by hand, but I gotta go. 21421 minus 17,966. Oh, I was off. Why was I off? Oh yeah, no, that makes sense. Okay. 3455. 3455. 17,966 is probably going to be 4 times whatever. Nope, 5 times it. 691. 5 times 3455. 5 times 3455 plus 691. And then 3455 is that looks to me like it will be 691 will go into it 7 times. Let's find out. 3455 minus 7 times 691. Nope. Oh, wait. Oh, yeah. Why am I? Okay. 3455 minus 7 times 691. Minus 6 times 691. Really? Oh, I meant 5. 5 was the number I meant the first time, not 7. I was thinking of 3,500. So, yeah. Little math mistake there. Okay, cool. 5 times 691. Yeah, I think there's got to have been a smarter way. Maybe not. I don't know. Who knows? Probably could have done all kinds of tricks along the way. Well, they're not both divisible by 3. You can do simplifications like on this one, I think that we could have found the divisibility by 3 rule is that 3 divides a number if and only if 3 divides the sum of the digits of that number n. So we could have divided both of those numbers by 3, and then we'd have a simpler algorithm. I don't know if it makes it a whole lot simpler, but cool. Well, we made some progress. We did this part, the GCD. I'm going to write them all out again. And I'm going to, say we've got 1, 3, 11, 3, 1, and 691. Cool. Now, let me see if the back of the book has an answer on this one so that we can check ourselves. Oops. Does the back of Dummit and Foote contain any... I think it does. Does it contain solutions to problems? Maybe not. Maybe it doesn't. But a lot of people out there have published solutions manuals, and I suppose I am doing the same thing as a bunch of other people out there. Oh well. Okay, so no solutions in the back of the book, but we could ask Wolfram Alpha or ChatGPT or something and find out if we got them right. But I think we did. I'll check it tomorrow. Thanks everybody for watching. I'm going to go ahead and sign off. I hope